All right, so we're here to talk about SOLIDWORKS CAM Standard, and it looks like we're gearing this for the EDU customers that are out there. My name is Ryan Cole. I am a senior application engineer here at GoEngineer, and just one of the tech guys, basically. So, really kind of want to do kind of a broad, kind of a introduction to the CAM system, what it can do, how it works, and possibly how you guys can use it out there. So we will go ahead and go through that. So why? So what we're going to do is we're going to talk about automatic feature creation, Z-level machining, and the tech database. To kind of give everybody an idea of what the CAM system is, basically the CAM system comes with every seat of SOLIDWORKS that's on subscription. So as long as you're paying for subscription, you do have access to this, and this is including all seats out there, including the EDU seats. It's not a low level, but it is a very limited to what it can do type of CAM system that can be upgraded and to other and higher end systems. It currently is a 2.5 axis system, which means that you can cut in the X and Y at the same time as you move your spindle around, and you can go up and down with your Z as well too. So it means that you can do pretty straightforward machining and even get into some higher level stuff, which is the Z level machining, which I want to show you guys, and we will talk about a little bit later. The main thing to understand about the CAM system, though, is that it's really built about a tech database. The tech database is basically the brains of the system, and what you're doing is you're kind of offloading the knowledge of the user into this tech database that it can then ping and figure out what's going on and come up with solutions for the user. It means that you don't have to be a high-end CAM person to really start, making parts on a CNC mill. What it allows you to do is kind of take the brunt of the work off of you or the user at that time, and get something together so that can get to a machine so that they can start machining pretty quick. Now you can do more advanced stuff. You don't have to let the computer make decisions and do everything for you. You can go through and manually create things as well too. But really, especially what I tell my users out there that are using this is when you have to offline it to do something manual, make sure you get that information into the tech database that allows it to come back a little bit later. So ultimately, while it is a CNC CAM system, really it works with the solid geometry on the screen. And we'll kind of walk through a little bit of that. And that really gets us into the first portion here, which is the automatic feature recognition. It is what's used ultimately by the program to get things set up to start working for the user. And a couple things that we want to talk about it is kind of what I've said a couple times here, which is it automatically recognizes component features. Meaning it knows what a hole is and what a fillet is and what a pocket is and what the facing and stuff like that. The other thing is it aids in the streamlining of the programming itself. Really, what you're doing is you're banking on the computer to understand what geometry is, and then it's going back to that tech database I spoke about a little bit earlier, and then it's coming up with a solution. And the solution is going to be, what is the strategy? How do we want to cut this? And we'll kind of walk through that here in a second. Ease of use is really what it comes down to. If you're looking to make a pretty quick part, pretty simple part, not a lot of effort has to go into it. A couple clicks of a button, and you basically have your G code go into your machine at that time. A manual creation and adjustments of the features is available, meaning that you're not just stuck with what it gives you. It is one of the few complaints that we have out there, especially for newer users getting into the CAM system. The complaint is like, well, it does it in ways that's not the way that I would personally do it. Well, that's the point of it. Chances are, in a lot of those cases, the tech database hasn't been manipulated for their particular machine for the way that they do things and stuff stuff like that. And that's where there's a little bit of education. We show them what they can do, how they can work with it, how they can get their way into that tech database so that when they go through and do this, it does it their way. So, kind of with that, let's go ahead and talk a little bit about what this looks like. So, I'm going to go ahead and bring a part up in SOLIDWORKS, and it's going to be a pretty straightforward part, but it does kind of show you the basic steps of what we go through. First and foremost, make sure that you do have your add-ins on. And you're going to go ahead and go up here to the add-ins and then make sure that the cam is on. I am in 2021, and this is the retail version of it. So for you guys, it will be here for you. Like I said, if you are on subscription, it is available and should work with no problem. When it's on, you'll know it's on because up here in the feature manager on the left-hand side, you'll have 3 extra tabs that weren't there before. And these are all related to the actual cam portion there at this time. So we've got let me go ahead and hover over it. We've got the feature tree, which is, this is where it identifies what it's cutting. Is it a fillet? Is it a pocket? Is it a face? Is it a hole? We also have our operation tree. This is where the strategies come in. So if you're doing machining, especially on a pocket or something, is it going to do a rough cut on it first and then come back in with a contour cut, which is going to be maybe a little bit slower, a little bit faster, a little bit smaller on the tool? Or is it going to do 2 roughs and then a finish, or is it just going to go in and do the finish cut? These are the strategies we're talking about, and it's also what we were talking about with the tech database, and we can see that that's up here, and we are going to look into that here shortly. So main thing here is when you're in the SOLIDWORKS CAM item here, there's a couple things. The first tab that's here is the one that we want to look at. When we go into it, you'll see that we have the stock manager, we have the coordinate system, we have the machine, we have the mill part setup as well too. In fact, if I come in here and go ahead and edit the definition of the machine, this is really kind of the first steps. You're telling it what machine you're going to be using. Now, if you're at a site that only has one milling machine, it's going to be pretty straightforward, but if you have a couple different milling machines, they may be different, may not be the same make, they may be a little bit different on the duty level that they can do, and this is where you can have those machines set up differently. We also have the tool cribs that are available as well too. This is going to be what tools are available for what particular machine. Maybe you have sets of tools that you can change in and change out, or maybe it's just simply a tray next to the worker that they'll have to go ahead and send it in, or put it in and pull it out. So this kind of tells what tools would be available. This is important because later on when we're doing the automatic feature recognition, it's going to need to know what tools are available to use while it's trying to figure out how to cut this. It may determine that you need a drill size or tool size that's too big than what you have, and if it's not in the crib, then it won't pick that particular size. The other important thing that we get into is what we call the post-processing. This is how do we get the information from CAM into the machine, and this is going to end up being part of your post-processors down here. Now, on my particular case, I have quite a few of them that are available. These are actually the stock ones that come with the software, and you should find one you should find one in here that should be close to what you're looking for, and it's going to take a little bit of testing. Worst case scenario, you can either talk to the maker of the machine to see if they might have a solution, and if they don't have a solution, you can definitely get a hold of GoEngineer. We've got a whole CAM department that's related to this, and they'll be able to get you up and running very easily, very quickly. Couple other items that are in here. You've got your setups, you've got your rotary and tilt axis, which actually don't apply to this particular version. We are in the standard version of the CAM package here. And then, like I said, it does 2.5 axis, it does some profiling. When you get into the CAM Pro version of the software, that's where we can get into lathe work. We can also do some rotary axis as far as turning parts to a secondary part and having it machine at multiple times. You've got quite a few items that are in here. So main thing that we're going to look at is machine, tool crib, and post processor. These are going to be really what you're going to focus on once you get this up and running. Now, the other thing that we have here is our stock manager, and this is really just telling the program how much stock we actually have for this particular component here. Now, in this case, I might put in a piece of steel or aluminum that's bigger than I need, and I'm going to mill that down to the appropriate size. But you do have a couple different ways depending on what you're dealing with here. So I can pull stuff from the part file, another part file. If I happen to be doing castings and I need to machine out a casting, I can bring in the stock shape of the casting in, and that allows me to have that, whatever size shape that I need. But we can also make sketches and extrude them out. We can also have set sizes as well too, predefined bounding boxes, even scan data as well too. If you happen to have scan data of a casting and you're trying to bring that in. I'm going to go ahead and leave it just on the bounding box alone, and we can see it in orange around my current geometry here. And maybe one of the things that I want to do is make sure that I have an absolutely flat top here. So the way that I can do that is come into whatever axis is towards the top, and I can add in a little bit of material. So I'm going to add in 1 millimeter. And we can see here that we've added that material in. The reason this is important is because we are going to need to cut that flat. And by having that information there, it's going to know that it needs to go ahead and clean the top of this off before it starts cutting any of the features in here. We'll go ahead and hit OK to that, and then we'll go through and make sure we get into our coordinate system, which is going to tell it where to be, where to go, what is my Z direction, where's my 0, 0, all that stuff. And here, in this particular case, we're actually telling it to go to the upper left corner of the bounding box. And we can see that even though we added that 1 millimeter in there, it's already there at the right location. So we're in a good spot there at this time. All right, that's pretty much everything we need to do. The next thing that we'll come through and do is go ahead and start telling it that we're looking for machinable features. This is the AFR at this time. So the automatic feature recognition is basically it's going to go through and read the data and the geometry and figure out what kind of things it's going to go through and cut. So it looks like we have a question here. It says, so the included CAM software does not support any turning operations or machines. The CAM standard does not support it. It is something that you can talk to your representative about. On the EDU side, I'm not sure if it has pro capability. So it's something that I can definitely follow up with, but I can try to get that answer for you. So after doing the extract machinable features, what I found was that it found different things. It found that it needed to do the face feature. This is getting rid of that upper information that was there. It knows that it has to do a perimeter. Maybe it needs to clean up the outside. This is something that I've told it to do regularly. And then we've got a rectangular pocket, and you can see that as I click on these, it is highlighting them on the screen. So there's the irregular pocket. Here's another irregular pocket over here. We can see it highlighted in blue, and then we can go through. So it looks like it found everything that we needed to here. Everything's looking pretty good. And now we can see that the next step of the procedure is here. So the generate operation plans, this is saying, hey, I want to cut this feature. This button will say, this is how you cut this feature. In fact, if I click over to here, you'll see that under the operation tab, there are no operations here. So once I hit generate operation plans, it'll go through, and this is now hitting the tech database at this point. And basically the tech database says, hey, if you do a face mill, this is the strategy that you use to cut. If you find a pocket, this is the strategy you use to cut. In fact, here we can see that the face mill has now turned into the upper portion here that they're facing off. We can see that there's a contour here that's on the outside, and there's a rough and on the inside, another rough on the inside to clean it up a little bit more, and then there's a contour, a final cut, and then it does another rough, and this time it's going to the pocket here. So it roughs it, and then it roughs it, and then it does a contour. Well, let's take a look at this. One of the things that I don't need to do here, I know that my material is going to be looking pretty good here, so I'm going to go ahead and hit delete, and we're going to go ahead and delete that particular feature. And that's going to bring it down here to the recycle bin. I know that the material is going to be good, so I'm not going to do any fine finishing on the outside here. And then I'm going to come back over to here and let's see, get rid of the rough mills. No, at the face mill. Yeah. So, and we can see that it's actually already gotten rid of the outside strategy that it was trying to find here. So this allows you to be interconnected. It's not something that I have to go back and clean up and try to get into it. So just as a quick update, it looks like the EDU licenses do get CAM Pro. So you would have access to the turning process or the turning operations there. So thank you, David. All right, so we've got our generate operating plans. Here's our strategies. The only problem that I have right now is that it's going to start with the face, and then it basically cuts these piece by piece. It cuts this pocket, then it roughs it, then it does a finish. Then it's going to cut another one, and then it roughs it, and then it finishes it, and then it roughs it, and finishes it. Now, if I'm switching my tools out, we can see that we go from a 50 mil face tool to 20 mil flat end to 12 mil to 16 mil to 20 to 10 to 10 to 20. So we're going to be doing a lot of tool changes. This is going to be very excessive on the machine. That's a lot of time that's got to stop, swing over, interchange the tools, bring it back, start cutting it, take it when it's done, switch it out. So what we're going to do is we're going to fix this a little bit. It's actually pretty straightforward. I'm going to go to the mill part setup, which is the side that it's cutting currently. We're going to go to sort operations, and then we're going to go to a sort tab. Now the sort tab allows us to pick how we want it to do things. So we're going to start with the face mill, and then it will do center drills, and then a drill, and then it'll do any counterbore or countersinking or reaming or tapping. And then we're going to get into the roughs and the contours, and then finally finishing off with anything else, whether it's a Z level or an area clearance. Now, the other thing that I'm going to go ahead and sort by is not only by the type of cut that it's going to be doing, but also by the tool size itself. And we can see here that it's taken this list of tools and it's put them into an organization for me. So I'm going to go ahead and hit apply and hit OK at this point. And now we can see that it's going to do the face mill, then it's going to do center drilling, then it's going to drill the holes, and then it's going to do all the roughs with a 20 millimeter. We can see that's just going to rough everything out at one time. Then we can see that it's going to do another rough with a 16 millimeter because it's got to get in between some of these islands that are here and continue on down. But what we've done here at this point is we've segregated out the tooling size itself so that now it doesn't have to switch out tooling between every step. And then we've also done the fast operations down to the slower operations with the holes on top. It's something that's pretty quick and easy, and it's able to get in there and get this exactly the way that you want it. So now that we have everything organized, and I did this organization first because the next step is to actually generate the tool path. So up to this point, we actually haven't said anything about how the tool is going to travel. We're basically identifying regions and saying, this is how I want it to go. And when I hit generate tool path, it will now apply the actual tool paths to the geometry, so we can actually see where it leads in, where it leads out, anything that needs to happen here. In fact, one of these you'll see is still blue. The blue is indicating that it actually isn't required. In fact, if I take a look at it, it goes through and it roughs this out the first time, and by the time it gets down here, there's not enough information to actually rough out, and it doesn't need to. So since there's nothing to rough out, we can go ahead and delete this, and that way it doesn't try to go through it, and it puts it back down into that recycle bin. This is important to have down here because if there is a change to geometry and it would want to use that, I can always do a right click on it and restore it from there as well too if needed. So we're going to go ahead, everything looks pretty good. In fact, if I hover over here, you can now see that the paths have been written in. If you want to make a change to any of them, it's as simple as making a double click on it, and then it will bring up the options for it at that time. So we'll give it just a sec here. There we go. So this is going to be, what is your feeds and speeds, what you're roughing, your numeric control. I'm sorry, not your numeric control. But yeah, your numeric control. You've got your feature operations. Are you doing zigzag? Are you doing, inside out spirals? All the information is going to be here. This is where you can make some fine adjustments if necessary. But once again, all this information is being pulled from the actual technological database. So when I make one of those changes manually, and it's something that I need to do all the time, that's what's going to lead me to go into that tech database and make that change. Last thing we'll do here is now that we've gotten our features, our operations, and our toolpath generated, the next thing that I'll get into is the post-processing. I'm going to go ahead and do the post-process. It's going to ask me to save a TXT file wherever it may be. This is going to be the file that you feed into your CAM side of things. And the one thing that I do want to kind of point out here is that SOLIDWORKS does come with a CAM NC editor. So if you have your own, you can definitely use that. But if you don't have one and you need access to it, this is going to actually be automatically here for you guys. I am going to say open G-code file in the editor. I'm going to go ahead and hit play. This is going to tell SOLIDWORKS to start writing the NC code out, or the G code at this time. And it'll take a little bit to get through there, so we can see it all there. It's all done at this time. And if anything, what I'll do is when I hit the OK, it's going to write the file, but then it's also going to open that file in that NC editor. So here we can see the actual NC code, or the G code, as it comes through. You can make manual changes to this if necessary. One thing that is nice to have here is we do have a back plot window that is available. So if I go ahead and pick on the back, holy cow, say that 5 times fast, back plot window, we can actually see the the plot lines here of what the tooling is going to be doing. And just like we could do in the program, we can actually see this go through and what's going to happen there. So we get a little bit of an idea of what each line of code is doing here, and change if necessary, but this will give us a good idea. Another thing that we can look at prior to doing that, though, is we do have a simulate toolpath. If I go into the simulate toolpath, I can kind of do the same thing, except this time I can actually see the tool moving around with it. You can see here that I'm doing the facing. I've slowed this down quite a bit, and we can actually watch the operations as we go through. This is kind of nice to have if you are looking for any kind of crashing situations that you might get into. This will definitely show you. In fact, there are buttons here and controls here that will tell you that if there is a crash, it will go ahead and stop right then and there and show you where the crashing condition is coming in. But you can see it is actually removing the material as we go through. I have a question here with, can the toolpath create trochoidal cutter paths? I don't have an answer for that one. I think the answer is yes, but it is something that I will have to look into. I think that has to do with, I think that comes with the Pro version, and that might, like I said, let me look into that, Nevin, and I will definitely try to get you some information. All right, so with that, we'll go ahead and speed this up, but basically this kind of allows us to see and make sure everything's going good, especially for the EDU sector. This could be beneficial in the fact that the students could now see what is going to happen before they start cutting it, and it gives them a good idea of what to expect and how it's going to do things. So that way everybody's kind of on that same page at that time. All right, so we'll go ahead and stop that. And that kind of really runs you through the main items there. When we talk about the AFR, if you're doing, kind of, simple parts like this, it's pretty straightforward. If you have multiple setups, say you have something on the side here that needs to be cut in, that's as simple as coming in and creating new mill part setups if necessary. You can edit the mill setups that are there. This is basically telling you, how many different setups you have. The nice thing is if you use the AFR, it kind of detects all this information automatically and will go through and make your setups as required. So the AFR is really nice because it will catch things that sometimes you as a user won't until after something bad has happened. So with that being said, let's go ahead and jump into something else here. This was pretty straightforward from the machining side. Let's take a look at something else. Let's jump back into the meeting. So Z-level machining, while we are 2.5 axis, this allows us to definitely have more capability than just plugging holes and making a pocket. So what do you have here? It allows us to machine a little bit more complex features. We're still staying within the 2.5 axis restraints though. So if anything is going on with the axes of your machine where maybe you're tipping the table to get into other areas. That's going to be outside of the SOLIDWORKS CAM portion there. So if you're getting into a true 3 or 4 or 5 axis machining setup, that's where you're going to want to really look at not SOLIDWORKS CAM, but get into the CAMWorks product. And just to kind of let you know, the CAMWorks product that's out there has been around for a long time. It's a third-party package, covers all your CAM needs. What we did was we took that part of CAMWorks out and we turned it into SOLIDWORKS CAM. So if you know how to use SOLIDWORKS CAM, basically it's a pretty easy jump into CAMWorks. It's the same interface, the same tech database even as well too. The other one is that it's adjustable as well too. So you could do some really rough cuts and do a little bit of finishing detail on it on the end of it. You can put in a really small tool and have it cut a whole bunch out. It's all up to you on how you want to do this. But let's go ahead and take a look at this real quick. And we'll jump into here. Let's go ahead and close this down. And what do we want to do here? Well, we want to cut this pocket out, and there's really not, I think this face might be flat, and this is flat, but it's at an angle to everything. And then we have a bunch of drafts in here and stuff like that. So it's not something that I could probably easily get in with a tool or something like that with the draft and the radiuses and stuff like that. So what I'm going to do is I'm going to come through, and I'm not really going to hit any of the other tools that I hit before. This is going to be a little bit special in this particular case. I am going to make sure that my machine is set up for the mil inch. I'm going to make sure that I'm using aluminum in this particular case, and the coordinate system looks like it's already been defined in the upper corner. So from here, what I'm going to do is hit the 3-axis mill operation. And then I've got the ability to say whether I'm doing area clearance, a Z level, flat area, whatever may be coming in here. So you do get a little bit of preview of what's going on here. So flat areas, it'll go over these bumps if necessary, or just cut away from the bumps. You've got your area clearance. This works really good if you have, if you're doing like 2-part molds or 2-part tooling or anything like that. And then you have your Z level, which is if you've got a complex shape that's just going to be difficult. So you can see that we're coming in and we're basically doing those Z cuts. In a case like this, we're going to use the area clearance, which is still using that same criteria there. We're going to come in and I'm going to have my tools that are available. I'm going to go ahead and say use the 1/4 inch ball nose that's available. And then I'm going to start to tell it what it needs to cut. So I'm going to go ahead and say we're cutting from this face up here. And we're going to go ahead and define the feature. And it's actually pretty straightforward. With a lot of the tools that are available, we can come through, grab an area. We're going to grab all those surfaces, and we're going to include this surface as well too, so it knows it's all together. Then we're going to go ahead and say OK to that. And then the last thing we'll do is go ahead and say OK to the final thing here. So it's going to go ahead and add in the area clearance here as a feature that we found. It'll go ahead and tell us how do we want to cut this out. As far as, what's the tool's condition? Is it, based on bounding box? This is where we can make that finessing in here and get it a little bit nicer. We can change exactly how it enters and retracts. Any the area clearance itself. How far does it go down? What is my overlaps that I have in here? I'm going to use the standard ones that are here, so I'm just going to go ahead and hit OK. And it looks like Paul helped out. On the trochoidal milling, it says yes, it is available with volume mill 2.5 access, which is available with the CAM Pro. So thanks, Paul. That's what I was thinking with the Pro capability there. All right, so we've got our feature. We've got what we're going to do with it, but because it's blue, I know that it hasn't generated a toolpath. So we'll go ahead and generate that toolpath. And this is a little bit more high-end than the other one. There's a lot more calculating going on, trying to figure out all the passes, trying to figure out all the geometry, but looks like it's finished it up in fair short order. And if I hover over it, we can definitely see that is the path it's going to take there. So we can see our ins and outs and how it goes through. Best case, worst case scenario, I should say, simulate the tool path. We'll turn the size up all the way, and we can see how it's actually going to mill that out. Now this is because it is using the geometry to remove that material. This will even show us what the finish may look like as well too. So with a 1/4 inch ball ball end on this. It's probably going to be a little bumpy. In fact, we can zoom in while this is doing it. We can kind of see how that's going to look. So it might be something where I want to change the number of steps, might even want to change the size of the tool as well too, just to get a finer finish that's on there. So it's going to really be left up to you guys to figure out which way is going to be best. But once again, it's not like you have to cut it and then go, nope, that's not what I was looking for. The simulation gives you a pretty good idea of how it's going to work for you right out of the bat. And once again, if you are working with students and stuff like that, this is really good information. It's good learning for them as well too, because they can see what they're going to be getting into before they even cut a piece of metal or even get the machine online. All right, so we can do complex shapes. We can do machine shapes, machine out parts and stuff like that. The last thing that we'll get into here is the tech database. The tech database, as I said at the beginning of this, is really the brains of the system here. This is where you are saying, here is how you do things. Here's the tools you have. Here's your speeds and feeds. Here's the machines we use. And then depending on the materials, everything goes into the goes into the tech database. Customized for your processes. You tell the tech database to cut the way that you want it to. And the thing here is, if it's not right, this is where you make the changes. If it's not doing it what you want it to do or the way that you do it, then you need to get that information into the tech database. So let's take a quick look at the tech database. I'm going to go ahead and click on it. It's going to take a second to bring up. And ultimately, it's pretty straightforward. You've got your mill machines, your turn machines, you have your mill tooling, you have your turn tooling, your speeds and feeds, and then finally your settings, which is going to be where is this located at, what language am I using, all that good stuff. But if we get into it, if you had a couple different types of machines on your floor and you wanted to account for both of them because they work differently, maybe one's a heavy duty machine, one is a light duty machine, this is where you're going to be able to go through. So if I click on the mill inch, it's going to bring up all the options for it. So you got some specifications in here. What's the horsepower? What's the average index time? This is all going to be used for when it does its simulations, when it does its calculations, when it does its G code. You've got your feed rates in here. You have your table travel as well too. So how much travel is available in here. You could be working on a little desktop micro milling machine, or you could be working with a big Haas sitting in the back. So all you're going to do is you're going to go through and make sure that all this information matches it. Once again, if there is any questions while you're going through it, you can always give us a call at GoEngineer. We'll be more than happy to help you out. If we get into the mill tooling, this gets into the different tools that are available here. We have our speeds and feeds. All of this is related to, oops, I updated that. Let's not update that. That could have been bad. All right, well, we'll let that update for whatever reason. But this is where you tell it the strategies that are involved. So when it does a rough, it knows that it has to use a particular type. When it does a rough cut, it knows it's going a particular feed and speed. It knows that it's doing a particular indexing as it goes down in the Z direction. This is really what is going to gel everything together. And once again, I have another question here. Can the tech database be used to simulate HP required for cut and material removal? That one, once again, Nevin, would have to get back with you on that one. Oh, the horsepower required for the cut and removal. That's probably one of the things I'll have to get with the CAM person for on that one. And we're still waiting for this to come through. So I could definitely ask one of the camp guys and see what's happening there. With everything, the way that it's all intermixed together, unfortunately, we're waiting for this. But that's where you can tell it's a heavy duty or it's a reduced duty. It's still going to be a person putting that information in. So as long as they know the information that needs to go into it, like I said, we're transferring data from a user into a technical database that can automate a lot of these processes. All right, so I will definitely do a follow-up on that one, Evan. I apologize for not having an answer right this particular second. So let's see if we can cancel this. There we go. Jump back into it. Yay. All right. So, ultimately, you're going to tell it what tools you have available here. You're going to tell it how you're doing things, what features use what the sizes of things are. You can put your tool holders in here as well too. So, with the tool holders, you have different tool holders for different tools possibly. So, all that information can be put in here. If you have custom tooling for some reason, you can put that in here as well too. A lot of times, basically, you can get all the information that needs to be filled out through here. You can actually get it from the tool makers themselves. You can say, hey, I need this information, and it's usually either A, supplied with it, or can be requested. So getting information in here, accurate information, isn't difficult. And definitely is, like I said, it's the brain. So if you are going to be getting into the CAM side of things, definitely make sure to understand that you will be in here. You're going to be making your machines. You're going to be kind of putting some pieces and parts together. And this is just going to get it closer to the 5-button click up at the top where you don't have to go back and check something or triple check something and make sure it's doing it the right way. This is where it's going to get it to do it the right way for you. All right. Oop, I guess I'm done. Ultimately, that's kind of what I wanted to show you. Kind of nice high level functionality, steps required to get things done. Hopefully, it didn't look super difficult. Like I said, probably the hardest thing is really making sure that you have a good post processor and starting to play with that tech database to get it more in line with what you guys are doing. So I would definitely keep an eye out for that. We had a couple questions come through. It looks like I do need to follow up on the last one from Mr. Steinbrink there. I will make sure I get some information over to you on that. But is there any other questions at this point in time? Definitely feel free to get a hold of us. If there is any other questions, feel free to get a hold of your representative. They will know exactly who to talk to and how to get information to you guys. So I would say I don't really have anything else at this time, so we'll probably end this at this time. We are recording this, so it should be available on our webinar page at our website at goengineer.com.